and welcome to the mathematics class. This class is for class 9 in continuation to the previous class of chapter Midpoint Theorem. In the previous class we have discussed 11 question A part. Now this is the last question, that is the B part. What is the question? They say that in the figure given ABCD is a kite. You can see ABCD is a kite. It looks something like a kite in which BC and CD are equal, and at the same time AB and AD are equal. It is given BC is equal to DC and AB is equal to AD. You have to prove that first point EFG is equal to 90 degree. Means we have to prove this angle as 90 degree. Now what do we do? First of all, we will draw the diagonals of the kite, and we know, or we should remember, that diagonals of the kite intersect each other at right angles. So AC will be the diagonal. I am drawing AC and BD. These are the diagonals and they intersect each other at 90 degree. This all, let it be point. The intersection point of the diagonals, let this point be M, right? Let this point be M, and let this be L, M, N, right? So what we have done first of all is construction, and in construction what we do? Draw diagonals AC and BD, AC and BD, which intersect at M, and rest we have named. Now in triangle DCB, what we all can see, E and F are the midpoints. So according to midpoint theorem, EF will be parallel to DB and half of DB. So in triangle DCB, we can say that EF will be parallel to DB and EF will be half of DB. What is the reason behind that? Midpoint theorem. By midpoint theorem. Now similarly we can see, it means we, okay, leave that, whatever it means. Now CBA, now we take in triangle CBA. In triangle CBA, we can see that this F is the midpoint and G is the midpoint. It is given that F and G are the midpoint, so we can say FG is parallel to AC and half of AC. Means again we can say that FG is parallel to AC and FG is equal to half of AC, and reason is midpoint theorem. Now we have proved that EF is parallel to DB, at the same time FG is parallel to CA. So from first, or let this be equation number 1 and this be equation number 2. From first we can say that if EF is parallel to DB, then LF will be parallel to MN. So we can say from 1, or from equation number 1, we can say that LF is parallel to MN, and similarly from equation number 2 we can say that FN is parallel to LM. Why? This total and this total is parallel, so this part LF is parallel to MN. Similarly, if G and CA are parallel, so this small part Fn is parallel to Lm. Now we have seen that in LMNF, we can see that pair of opposite sides are parallel. These two are parallel and these two are parallel. If they are parallel, so we can say that L, F, N, M is a parallelogram. We have proved that this LFNN is a parallelogram. And in a parallelogram, we know that opposite angles are equal. And this angle is 90 degree. We can say that angle LMN, LMN is equal to 90 degree, because we know that in a kite the diagonals intersect each other at 90. So these are the diagonals. So point M where diagonals are intersecting, this will be 90 degree. If this angle is 90 degree, then angle opposite to it is angle F. Angle F will also be 90 degree because these are the angles of parallelogram. So you can say is equal to angle LFN. LFN. And reason you will say opposite angles of parallelogram. You want, you can even write opposite angles of parallelogram are equal. So when LMN, this is 90, so we have proved this also 90, which implies that angle EFG is equal to 90 degree. This is your proof. First part has been proved. Now we will move on to the second part. They say a line drawn through G parallel to EF. Through G, EF is this, so parallel to EF means it has to be something like this. Let us name this point as H. So a line drawn from G parallel to EF means these two lines are parallel. We have to find a line drawn from through G parallel to EF bisects DA. It means you have to prove that H is the midpoint of AD. Let us see how it is like that. Now in the second part, what we have done, we have constructed GH parallel to EF. So we'll write construction GH parallel to EF. Now we have to prove that EF bisects DA. Line GH which is parallel to EF bisects DA means we have to write that, or we have to find that H is the midpoint of DA. What you can say in this is the midpoint and this line is parallel to this line. At the same time this line was parallel to this line. So we will write down the proof. What is the proof? We know that EF is parallel to DB. How? That was proved above. Proved above. At the same time, we know that GH is parallel to EF. This is given in the second part. They say a line drawn through G parallel to EF. They have said that GH is drawn parallel to EF. So from these two we can say that GH is parallel to DB. It means this HG or GH is also parallel to DB. Now, if GH is parallel to DB, according to the converse of midpoint theorem, we know that if a line is drawn from midpoint of one side of a triangle and is parallel to the second side, it bisects the third side. So we will say that in triangle DAB, in DAB it is given that G is midpoint of AB, first point, and second it is given that HG is parallel to DB. So we can say that therefore H is midpoint of DA according to converse of midpoint theorem. Now H is the midpoint of DA. It means H bisects DA, and that is what we have to prove. Therefore, we can say that GH bisects DA. This has been proved. Now one question is left, that is question number 12. You all will do this question on your own. This is only based on calculation. That is why I am not taking it, and with this your chapter finishes. The next chapter, that will be your Pythagoras theorem. In the next class we will start with the Pythagoras theorem. So by that time, keep on studying, be at home, stay blessed. Thank you.